Hello students, so we were doing exercise 5.1. So next question is question number 10. Find all the points of discontinuity of f, and f is defined as f of x equal to x plus 1 if x is greater than or equal to 1, and x square plus 1 if x is less than 1. Okay. So we have to find left hand limit, right hand limit around 1, okay, and at that point. So starting with left hand limit, for left hand limit extending to 1 minus, will take this, right? Sorry, x is less than 1 means x square plus 1 we have to take. Okay. So this is 1 square plus 1, so 2. Okay. For right hand limit as x tends to 1 plus, you have to take this function x plus 1. So this is also 2. Okay. Now check for f of 1. F of 1, you have to take this x plus 1. So 1 plus 1 is 2. Okay. So we have left hand limit is equal to right hand limit is equal to f of 1. Okay. So it is continuous at point 1. So there is no point of discontinuity here. Okay. Question 11. Find all the points of discontinuity of f where f of x is x cubed minus 3, x is less than or equal to 2, and x square plus 1 if x is greater than 2. Okay. So now we have to take point around 2. So start with LHL, left hand limit, where we are approaching from the left hand side extending to 2 minus. So we have to take first function, that is x is less than or equal to 2, x cube minus 3. So 2 cube minus 3, 8 minus 3 is 5. Okay. For right hand limit is extending to 2 plus, we have to take x square plus 1. Okay. X square is 2 square plus 1, which is 4 plus 1, 5. Okay. Now you have to check for f of 2. F of 2 you have to take again this. So 2 cube minus 3 will get 5. Okay. So again here left hand limit is equal to right hand limit is equal to f of 2. So we can say that 2 is a point of continuous. At 2 this function is continuous. Okay. So the given function has no point of discontinuity. Next question, x raised to 10 minus 1 and x square they have given. Okay. So again here the same thing, LHL limit is extending to 1 minus x raised to 10 minus 1 function you have to take. So 1 raised to 10 is 1. So this is 0. Okay. What about RHL? Limit is extending to 1 plus RHL you have to take x square. So this is 1. Okay. For f of 1 you have to take x raised to 10 minus. So 1 raised to 10 minus 1, 0. So LHL is not equal to RHL. Okay. So we can say that at x equal to 1 function is discontinuous. Okay. Next function x plus 5 and x minus 5. LHL limit is extending to 5 minus x plus 5. So 5 plus 5 is 10. Then this is 1. Is tending to 1. 6. RHL, we have to take this x minus 1. 1 minus 1. So minus 1. Okay. At f of 1, you have to take x plus 5. So 1 plus 5, 6. So again here LHL is not equal to RHL. So we can say that at x equal to 1 the function is discontinuous. Okay. So for this 3 values are given. Okay. So you have to take values like 1 and 3. So start with limit as extending to 1 minus. 1 minus means you have to take this. So LHL as limit extending to 1 minus, you will get 3. Okay. RHL as limit extending to 1 plus. So we are going, we are approaching from the right hand side. Then we have to take this function 4. Okay. Now if you take LHL as limit extending to at x equal to 1, it is again 3. Okay. Now limit is this less than 3, you have to take again 4. RHL 3 plus, you have to take 5, and at f equal to 3 it is 5, right? Okay. So at x equal to 1, LHL is not equal to RHL. So we can say that function is discontinuous. Same way, at x equal to 3, LHL is not equal to RHL. So function is discontinuous. Let's do this. So for x less than 0, continuity we have to check. No? So you have to take limit 0 at point 0 and at 1. Okay. So first is for point x equal to 0. So LHL as limit extending to 0 minus. You have to take 2x. So this is 0. RHL as limit tends to 0 plus. 0 plus 0. Then at f of 0, it is 0. Okay. For x equal to 1, LHL as limit extending to 1 minus. You have to take this function 0. RHL, this is 4x. Limit as extending to 1 plus. 1 plus it is 4x. So 4 into 1, 4. Then at 1 it is 0. Okay, here LHL is not equal to RHL. So function is discontinuous at point x equal to 1. Okay, here all are equal. LHL equal to RHL equal to f of 0. So function is continuous at x equal to 0. Okay, let's solve this. So here also same thing, you have to check it minus 1 and plus 1. Okay, for x equal to minus 1, LHL limit is extending to minus 1 minus, you have to take minus 2. So minus 2 RHL limit is extending to minus 1 plus, I have to take 2x. So 2 into minus 1 is minus 2. Okay. For f of minus 1 at x equal to minus 1, you have to take this minus 2. Here all are equal. LHL is equal to RHL is equal to f of minus 1. So we can say that function is continuous at x equal to minus 1. Okay. For x equal to 1, limit is extending to 1 minus. 1 minus is 2x here. So 2. What about RHL? Limit is extending to 1 plus 2. Okay. F of 2, you have to take this. So f of 1, sorry. F of 1, 2 into 1, so 2. Here also LHL is equal to RHL is equal to f of 1. Okay. So we can say that this function is continuous at x equal to 1. Let's solve this. Fx equal to ax plus 1, bx plus 3, x is less than or equal to 3, x is greater than 3. Okay. So you have to find a relationship between a and b. And it is given that this function is continuous at x equal to 3. So continuous means what? LHL is equal to RHL is equal to f of 3. Okay. So start with LHL. Left hand side limit is extending to 3 minus. So it is ax plus 1. So a into 3. 3a plus 1. Okay. What about RHL? Limit is extending to 3 plus. So bx plus 3. 3b plus 3. Okay. So we have to equate this to this. F of 3. What about f of 3? F of 3, you have to take this function ax plus 1. So 3a plus 1. Okay. So 3a plus 1. Yeah. 3a plus 1 is equal to 3b plus 3. If I take LHL is equal to RHL. Okay. Then this is 3a minus 3b equal to 3 minus 1. So this is 3, you can take common. A minus b is equal to 2. So a minus b is 2 by 3, or you can take, yeah, a minus b is 2 by 3, or a is equal to b plus 2 by 3. Okay. Next question. For what value of lambda is the function defined by f of x equal to lambda x square minus 2x if x is less than or equal to 0, 4x plus 1 if x greater than 0, is continuous at x equal to 0. What about continuity at x equal to 1? Okay, it is given that x, no, it is not given. You have to check, is it continuous at x equal to 0? And also you have to check at x equal to 1. So LHL limit is extending to 0 minus. 0 minus, you have to take this. Lambda x square minus 2x. Okay. You can take common x. So this is x minus 2. What about RHL? RHL is limit as extending to 0 plus 4x plus 1 you have to take. Okay. So yeah, 4x plus 1. What about x equal to 0? This function lambda 0 minus 0. So 0. F of 0 is 0. Okay. So if if it was continuous at x equal to 0, then LHL is equal to RHL is equal to f of 0, right? F of 0 is 0. So if I equate it to 0, this lambda x minus 2 is equal to 0, then this lambda is also 0, correct? Uh, Here also if I take for x plus 1 equal to 0, then x is minus 1 upon 4. Hmm? Yeah, if I take here 0, so we are getting lambda equal to 0. If you put here it is x equal to 0. Here also if you put x equal to 0, we'll get, we have to put 0. This is 0 and this is 1. So if it was continuous, then these three values would have been equal. But these are not equal, right? These are not equal. So we have to check the value of lambda, okay, for x equal to 0. So x equal to 0, there is no value of lambda because here we are getting the function is not continuous at x equal to 0. Okay. Check for x equal to 1. X equal to 1 if I put, then this is f of 1 is x greater than 0. That function you have to choose because this is greater than 0 means 1 is included here. So 4x plus 1, so 4 into 1 plus 1, so you are getting 5. Okay, and so for f of 1 you are getting 5, right? Let's check for extending to 1. Extending to 1, that is right hand limit, we will get the same thing, and left hand limit also you will get the same thing because this is greater than 0 means both are included. Approaching from the left hand side, approaching from the right hand side for 1. Okay, for both you have to take the same function. So here if you take 1, then LHL becomes equal to RHL becomes equal to f of 1. So we can say that f is continuous at x equal to 1 because we are getting 5. Okay,